Welcome back to the Scotti-BYTE channel, and this is Scott. Well, it's been about 2 weeks since the last video, and one of the reasons for that was I was trying to figure out where exactly I should go next. And one of the subjects that has come up on the channel from some of the comments I've received is the subject of LXD Port Forwards. And this is something we don't often talk about because we've learned how to bridge LXD containers to your LAN. In previous videos, I talked about how to bridge a container to a LAN, getting an address on your main LAN, and also using Mac VLAN, how to get an address on your VLAN. And LXD containers with dedicated LAN addresses look a lot like bare metal or virtual machine instances. And one of the reasons for that is because it is a user space-based operating system instance. It's not a virtualized application. It's really more of a virtualized operating system. So Docker containers frequently use port forwarding by default from the container to the Docker host. And if you look at a Docker compose command, you can always see that there is an internal port number that the application uses, and then it presents that to an external port number on the Docker host itself. So LXD containers default to an internal NAT, just like the Docker containers do. They have internal addresses that aren't reachable from your LAN. And in order to get to that LAN outbound, they use the LXD BR0 bridge. So LXD can also forward selected ports to the LXD host if instead you've decided that you want your LXD container to have an internal NAT address and not present out onto the main LAN. So here's a diagram that I want to talk to explain a little bit about what I'm talking about. So at the top, we've got a router, and we're looking at that router presenting itself with a gateway address on the main LAN of 192.168.1.1. And here we've got a network on the left-hand side here at 192.168.1.50. We have a Docker host, and at 192.168.1.60, we have a LXD host. So first of all, the Docker host looks a little bit different. So these addresses that you're seeing are addresses that Docker would assign as an example on its internal Docker address range, which would be a network address translation network. So nothing from the 192.168.1 network would be able to initiate contact and connect to one of these Docker containers inside. So that's why when we look at things like these two Docker Compose examples I've given here, one for Tautuli and one for Nginx Proxy Manager, you can see that we say that inside the container here, in the case of Tautuli, it's using port 8181, and externally it's using port 8181. And we can change that number to the left-hand side. But to say it's using that externally means that on this Docker host of 192.168.1.50, if we access port 8181, it goes down to this Tautuli container, which is actually running on the internal Docker address of 172.17.0.5. And likewise, over here we have Nginx Proxy Manager, which decides to expose three ports, 80, 81, and 443, which are used internally, and we're actually exposing those at their same exact addresses. But suppose that we had a third container here, suppose this one running at 172.17.0.6, and suppose it had an application that wanted to also be able to expose something at port 80. We couldn't do that because port 80 was already being used by this, And in order not to conflict with the ports on 192.168.1.50, we would actually have to pick a different port number. So we might say 80 would be exposed as port, say 8080. And that's the game you always have to play with Docker hosts. And so for that reason, I usually suggest that we present our LXD hosts bridge to the main network, getting their own unique addresses. So that being said, before we press ahead, there is an advantage to this particular situation. And the advantage is if we have one of these containers that talks to another container, suppose they make a SQL Server connection from this container to this container, that SQL Server channel would be completely protected on the Docker network inside of the Docker NAT. And actually, by allowing your containers to have addresses inside this NAT, you can control the communication between various Docker containers or Docker containers inside of the Docker host. So that's a way to actually add security. Now, if we move over here to the right-hand side of the diagram, you can see that this is a LXD host, and it also has an internal NAT. And in this case, I'm just arbitrarily saying that that's going to be 10.45.70.5, 70.6, 70.7, and so on. And likewise, you can't have something initiate communication from here and contact one of these containers. So in past videos, what I've shown is that we can make a connection by taking one of these containers and instead using bridging to present it with an address on the main LAN. But you can't always necessarily do that. And one example of that was pointed out to by one of my listeners was if you're using a VPS, a virtual private server, and you're out on something like Linode, you might be able to fire up a LXD host, but you might not be granted multiple addresses that you can provide public addresses out on the LAN. You may only have one address. So with that in mind, you could have multiple LXD containers running inside of the LXD NAT network, and they're bridged using LXD BR0 out to the main LAN. And all that means is these containers here can freely communicate outbound, but they can't necessarily communicate inbound. Docker takes care of that by having this external address here, and LXD takes care of that with a similar type of command. And as an example here, I have where we launch a container, we say LXC launch Ubuntu 2204. We call the container test1 and just set boot.autostart equals to true, which means whenever the LXD host starts up, so does the container start up. And if example is that 10.45.70.5 is our container, it's not going to be reachable from the 192.168.1.0 network. In other words, this network here. However, it can freely do outbound communication just like a Docker container can do. However, we can create a proxy. So in the past, when I've covered profiles, I've covered profiles for other types of networking. And in this particular case, we're going to say LXC profile create, and I'll create a profile called proxy 8080. And then I'm going to add to that proxy 8080 something called host port 8080, and that's just what I'm naming it. And I'm going to say it's a proxy, and its job is to connect 127.0.0.1, which is the loopback connector, or another way of saying connect myself. In other words, connect the container to port 80, and take that port 80 and allow anything from the outside to connect to it on port 8080. So in essence, we're saying that if somebody accesses 192.168.1.60 port 8080. They're going to be connecting to port 80 on this container on the inside of that LXD NAT at 10.45.70.5. So let's see how LXD port forwarding works. So first of all, we're going to create a container called test1, and we're going to make it with Ubuntu 20.04 with LXC launch Ubuntu 20.04 test1, and we're going to set the boot.autostart equals to true, which causes that container to automatically start when the LXD host boots. So here we are creating the new container, and this container will create itself not with a LAN address, but with an address on the NAT address of the LXD network. So if I do LXC list, you can see that the last item here is test1, and it has an internal container address of 10.251.221.109, which is an address that is not reachable from my LAN. And just to prove that, we'll bring up a terminal on my local machine, and we'll do a ping of 10.251.221.109, and you can see that we can't ping that address, of course. Now, our LXD host, which is 172.16.1.50, we are able to ping because it has an address on the main LAN. From the LXD host, I'll now do a LXC exec test1 bash, which connects to the console inside of the test1 container. I will do an apt update. Don't need a sudo since I'm already running as a root by having done the exec command. I should always do an update on a new container. And once I've done the update, I'm going to do the upgrade to upgrade the 13 packages here that say that they can be updated. Okay, next I'm going to do an apt install on Apache 2, just so I have something here that I can connect to. And we've installed the Apache web server with that command. So even though I've installed the Apache web server, if I turn around and try to ping 10.251.221.109, it's still not accessible because, of course, it is not on this network. And I'm still able to ping 172.16.1.50, which is the LXD host. So essentially, nothing has changed as of yet. So now if I log off the exec session on the container and come back to the LXD host, the next thing that I can do is I can create our profile that we had talked about with a LXC profile create proxy -8080. And that's just what I'm calling the name of the profile that I'm creating. And the next thing that I'm going to do is add the settings to that profile. And my settings are going to be LXC profile device add to the profile we just created, proxy 8080. And I'm just creating a label called host port 8080, but it is a proxy where it connects to the current node, meaning the container itself, port 80, and allows it to be listened for on the host up at port 8080. So if we want to see what that profile looks like at this point in time, we can do a LXC profile show proxy 8080, and you can see that there's a device called host port 8080, and there's the connect address, and there's the listen address, and it is a proxy. So we haven't yet applied it to any container, but we have our test1 container. In order to apply it to the test1 container, we simply do LXC profile add test1 proxy 8080, and it says that it has been added. If we want to verify that, we can then also do the command LXC config show test1 space -e, and it will list the devices, and you can see that one of the devices inside the container is ETH0, and it's on the LXD BR0 bridge network, which is normally an outbound network only, as we talked about earlier. But then we have this other device called host port 8080, and it is the proxy that we just finished defining. The way we can verify if our proxy works is by going to the address 172.16.1.50 port 8080, because port 8080 is what we're exposing, down to port 80 inside of the container, and that's where our Apache is running. So if I say 172.16.1.50:8080, you should see it come up with the Apache web server, and it does, meaning that our proxy is working for our LXD container. In order to remove this proxy from the container, we can do a LXC profile remove from the container test1 proxy -8080, and we do this from the LXD host. Now it says that the proxy's been removed from the host, and if we come back up here and try to do a reload of this page, it will come back and say that this site cannot be reached, letting us know that we no longer have access to the Apache inside of the LXD container as expected. And finally, assuming I wanted to remove the profile because I wasn't going to use it for any other containers, I could do a LXC profile delete proxy -8080, and it would delete that proxy. So in summary, I think LXD containers bridged to dedicated LAN addresses are more powerful. But there are times when LXD containers on their internal NAT network bridging selected ports via LXD BR0 to the LXD host can be a better security model, and a specific example of that is not so much for the security model but for the functionality, and that would be in the case of using a VPS where you might not have the addresses available to use. And so by using this technique, LXD port forwarding can use port forwarding similar to how it is done within Docker. And normally we don't really consider that because of the fact that you can run anything that you want inside of a LXD container in terms of applications, and it just looks more like a regular operating system. So forwarding selected ports is generally not the way it's done. However, there's nothing that prevents you from doing so. So this method is of particular value, as I mentioned earlier, on a VPS server outside your network, because multiple LXD containers can project their selected ports out through the one LXD host address. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.